Hey guys, this is Mr. Lowry again. Hope you're having a great day. We got an assignment here, and before we get too far into it, let me just remind you, or if you weren't here, you don't have to do the back. Now, if you weren't here and you got the one that I posted in Canvas, it actually doesn't have this back page. I actually just edited it. The reason why is we just didn't get this far in class, but that's okay. We can talk about this another time. So we're just going to do the front side. If you were in class and you got this, if you're at home and you downloaded this, then again, it's not going to matter because you're not going to see a back side. Okay, so just doing the front side, 1 through 16 on this assignment. Okay, now what we're doing with this one is the idea is to divide complex numbers and imaginary numbers, or dividing with those two things. That was the main point of today. We had to kind of take a detour at times to talk about a concept called factoring, which we'll talk about as we get into this problem set down here. But one of the ideas about imaginaries and complex numbers is we don't leave an I in the denominator. So a growing list of things we don't leave in the denominator. So don't leave in denominator. Radicals, so like irrational numbers, like square root of 2, we need to rationalize the denominator. Factors of -1, like we don't want to leave like a -5 down there, or -15. We want to kind of cancel out the negative. We don't leave negatives in the bottom. And then the other thing we don't leave in the bottom is imaginary numbers. So we have techniques for dealing with all these things. We already know the technique for here. It's called rationalizing the denominator. We're going to use techniques for these two today. One of the things that's really kind of interesting about imaginary numbers is that when you multiply two together, you get a real number back. So if you recall, I squared is equal to the number -1. So if we keep that in mind, it's actually kind of makes sense what we're going to do here. What we're going to do, because we don't want that I in the bottom, is we're going to get rid of that I in the denominator here by multiplying it by I. But we have to make sure we do that on top and on the bottom here so that we are really kind of multiplying by like a form of 1. Now this is a little weird because I over I, those are imaginary numbers, not real numbers, but this idea of using the kind of like a version of the identity property is still going to work out for us. So we got 20 times I. All right, and then we're going to divide that by 16I squared. So when we have a 16I times I, we're going to get I squared. So now we have an imaginary number on the top, and on the bottom, I squared is actually going to be a -1. So the whole I squared piece just turns into a -1. So now I have 20I over -16. So we got to look for common factors here. And one thing that we also want to keep in mind is that we don't want to leave a negative number in the denominator. So we need to cancel out that negative or somehow deal with that negative. If you recall, a negative, when you take a positive number and you divide by a negative number, the answer actually comes out negative. So as a simpler example, if I had 12 and I divided by -3, the answer would be -4. So positive divided by negative is actually a negative number. So when I see a positive divided by a negative, I can actually just think of this whole fraction as a negative number, put the negative out in the front. Or another way to write it is you can put that negative kind of with the top guy. And it seems kind of weird that we can just move that negative around kind of wherever we want. But really the reason why we can do that is a positive number divided by a negative number is just a negative number. So it's kind of how division with negatives works. So we can kind of move that negative around. But we also see that there's like a factor of 4 here because 4 goes into 20 and it goes into 16. So if we wanted to factor this out, we could say that this is a 5 times, excuse me, let me back it up. -5 times 4 times I on top. And on the bottom we have like a 4 times a 4 right? If you want to think of it that way, you can cancel out the 4s. Another way to think about it is 4 goes into 16 4 times, 4 goes into 25 times. Don't forget the negative. All right, there you go. So what we're going to do here in on all these problems 1 through 4 is we're just going to multiply the top and bottom by I over I. All right, now in the last video, if you watched that video, we talked about how we use these videos to become independent, okay? So we don't want to be dependent on the videos, we actually want to learn and grow and be better by the time we're done. So I just showed you how to do one. What you should do is you should now try another one. If you're not sure if you know what you're doing, try it first and then check back with the video or check on the answer key and just do one at a time until you get the hang of it. So right now what I would do is I would pause the video and I would try number 2. Okay, you should have tried number 2 now. Let's do it together and see what you came up with. See if you're right. Okay, so again, we're going to multiply by I over I. Now, when we rationalize a denominator that has radicals in it, we have to do a little bit more thinking. But for these, it's pretty much just I over I every time, because all we need to do is get an I squared. So this is going to be equal to negative 6I on top, and then on the bottom we have negative 14I squared, right? I times I. So the I squared is just negative 1, so once we have that I squared, let me zoom in here. Once we have that I squared, we're just going to replace this with negative 1. So it's negative 6I times negative 14 times negative 1. Okay, so I got a negative 6I on top. Negative 14 times negative 1 is a positive 14. And now I just simplify the fraction. So what goes into both 6 and 14? The answer is 2. So 2 goes into 6 3 times, but don't forget that negative. And don't forget the I. And 2 goes into 14 7 times. Okay? So how'd you do? Did you get it? Did it make sense? Did you make a mistake? If you got it, great. Looks like you're on your way. If you got it wrong, then see if you can find out where you went wrong or what part of the problem you didn't understand. If you can figure out what you didn't understand, then you kind of have just fixed the problem for the future. Okay? All right, let's do one more together here. 3 you have the answer for, so I'm going to do 4. But again, before I do 4, you should try it on your own. You've got 2 examples under your belt now, so try it and see what you can come up with. All right, coming back from pause, you should have done number 4, maybe number 3 already, and checked your answers. Let's see what you came up with. So here what I would notice is I got a negative out front. Now, we can consider this like this is negative of the whole fraction, or we can kind of put that negative up in the top. We could also put it in the bottom, but that's not really conventionally how we do it. So something like this. All right, now we have to get the I out of the bottom. That's the whole point. So again, we're going to multiply by I on the bottom, because I times I, we're going to have the imaginaries cancel out, but we also have to make sure we do that on the top as well. All right, so negative 12 times I is negative 12I. Okay, on the bottom I have 3I squared. Okay, recall that I squared is equal to negative 1. So anytime I have an I squared, I'm going to replace it with a negative 1. So 3 times negative 1. I'm going to get rid of this. This was just some brainstorming we were doing over here. All right, so I got a negative 12I over a negative 3. Okay, now when we have negative divided by negative, they cancel out. So negative 12 divided by negative 3 is actually just a positive 4. So we're going to get a positive 4 or positive 4 over 1. But don't forget that the 4, we got an I here. So I would say that the negative 12 over negative 3 is 4 over 1. And we still have that I. But we don't really need to write the 1. So just 4 times I. Okay, so ask yourself, are you confident on those? Have you mastered those? Do you need to practice some more? If you haven't mastered them yet, where are you having problems? What is the question that you have? What problems are you having? And if you can't solve those problems on your own, then you can let me know and we can have something to talk about. Sometimes you just need more practice. So if you've got those 4 problems done and you want to do some more, I would recommend just getting a spare sheet of paper and just trying them again until you have them dialed in. All right, let's take a look at the next 6 here, okay? Now these ones, they're all slightly different. Like if you look at 5 and 6, they have x's in them. 7 and 8 have roots in them, and then 9 and 10 have i's in them. But they actually all work the same. And the really important property, or I guess technique that we talked about today, is undistributing. Undistributing isn't exactly a formal math word. The actual word is factor, but we kind of talked about how this really looks like undistributing today. So undistributing is the opposite of distributing, or factoring is the opposite of distributing. What you'll notice is that each of these problems here, we're going to do the evens, they have what we call a binomial denominator. So binomial is 2 different terms, or 2 different like pieces that are added or subtracted. Okay, and so in order to simplify, we have to factor out a common factor. Now, if you don't know how to factor a binomial, or if you miss class, I would highly recommend that you go watch the video that I posted with the notes today. Okay, that's going to help you out a ton. If you don't know how to do that, this is probably not going to make a whole lot of sense. So go back through the notes first, or watch that video, or probably both would be the best before you come back to this video. If you were in class today, then you know that there's actually a couple steps here. Okay, step 1 is to undistribute the GCF from the numerator, and then step 2 is to cancel out the common factors. So actually, I was going to write down the steps, but I actually kind of have them here. Factor out GCF from the numerator. 2, simplify the expression. This is going to be canceling, okay? But we also have to watch out for negative denominators. Okay, so if I look at the numerator here and I see a 9 and a 5, there actually isn't a common factor other than like 1. Okay, so we could factor out a 1 here, but that would be very interesting. But what we do notice is that there's a negative on the bottom. So the GCF, the greatest common factor of 9 and 5, is actually just 1. But because there's a negative on the bottom, I want to make sure that I factor out a negative 1. So anytime there's a negative on the bottom, you need to factor out a negative number to cancel the negative on the bottom. Let me show you how that's going to work in this case. So if I undistribute a negative 1, that's kind of like dividing out a negative 1. So I'm going to put a negative 1 on the outside here. You could also just put a negative symbol, but negative 1 maybe is a little more clear. So 9 divided by negative 1 is actually negative 9, and we have an x. 5 divided by negative 1 is negative 5, and we have that all over negative 5. Okay. The reason why we're doing that is because we need to cancel out this negative with this negative. So we're going to have a negative 1 times negative 9x minus 5. Now notice that these 2 things are factors now. This piece and this piece are factors. It was like we had a kind of a sum here, 2 things getting added, but now we have a chunk multiplying another chunk. On the bottom, we might notice that there's a common factor here of negative 1. So this is actually kind of a tricky problem because it's hard to see the common factor. But we'll do a couple here so you can get the hang of it. So the negative 1 cancels with the negative 1. And so this is kind of hard to see. Those both had negatives on there. So what we're left with is we got a negative 9x minus 5 all over 5. Now it's really tempting to want to cancel this 5 and this 5, but you can't do that because of this subtraction symbol, because these 2 pieces are separated by a subtraction here. We actually have 2 terms both being divided by 5. And if we cancel out the 5 here, then the negative 9x will no longer be divided by 5, and we're changing the problem here. So the only way we can cancel stuff out when we have an add or subtract, or what we call a binomial numerator that has 2 pieces, is you have to be able to factor it out of both terms, and then you can cancel it. Okay, that one was kind of tricky. So let's actually go back into number 5, which I think will make a little bit more sense, and then we'll go through and we'll do the rest of the evens. Okay, so when you look at these guys right here, negative 6x and 8, the common factor here is 2, because 2 goes into 6 and 8. It's actually the biggest thing that goes into both. So I would say the GCF, greatest common factor, is 2. Okay, now look at the denominator. Is it negative? It's not, so we don't have to worry about factoring out a negative. So what we're going to do is we're just going to undistribute 2 from the top. So it's like dividing out a 2 from both terms. So negative 6 divided by 2 is negative 3. And don't forget the x. And then 8 divided by 2 is 4. And since it's positive, we're going to add those two. Okay, so we found the greatest common factor of the numerator. We undistributed it, or factored it, and now we can cancel out these guys. Okay. Now again, we can only do that because the 2 is now multiplying all of this stuff. We have factors. Here, we don't have factors. We have two different terms. Here we have two things multiplying each other. So that's kind of what we wanted. So the answer here is the negative 3x plus 4. Okay, now these next two problems here, we're going to do 8 and 10. These next two guys look a little bit different because they don't have an x in it. But if you have an irrational number that's simplified, like root 7 or root 3, or if you have an imaginary unit like I, we're going to treat those the same way we treat variables. So pretend that root 7 is just an x. What is the common factor here with negative 30 and negative 6? It's actually 6. So we're going to factor out a 6. So greatest common factor is 6. It goes into both of them. Okay. Now you might be thinking, well, can we take out a negative 6 since they're both negative? And we actually could. We could take out a negative 6 if we wanted. The problem with that, well, I mean, it would work. You could actually do that. We don't have to do that in this case because we don't have a negative on the bottom that we have to cancel. So I'll show you a couple different ways to write the answer. But for now, let's just keep the greatest common factor is 6. Okay, if you want to factor out the negative 6, I think you still could in this case. So when we undistribute a 6 from these, we're going to have a 6 on the outside, right? Pull out the 6. So when we divide out that 6, basically undistribute it, we're going to have a negative 5 minus root 7. So negative 30 divided by 6 is negative 5. And then when we divide this 6 out, we're left with negative root 7. Okay, notice that on the bottom here there's a 12, which is 6 times 2. So the 6 up here can cancel with the 6 in here, leaving us with a factor of 2. In other words, 6 goes into 6 one time and 6 goes into 12 twice. And so what we have is negative 5 minus root 7 over 2. So if you factored out the negative, you could do that. One way to write that would be to write negative 1 times 5 plus root 7 over 2. So you could kind of put some parentheses in there. But I think this is probably the better way to write it in this case. Okay, so the steps were the same, right? We start by finding the greatest common factor of the top two terms. We undistribute it, and then we cancel anything that's on the outside that can cancel. Any common factors of the top and the bottom. All right, we're going to do the same thing here. So what is the greatest common factor of these two numbers? The greatest common factor here is 4. Now we could actually factor out a negative 4. And in this case, we're actually going to want to do that. And the reason why is because the bottom is negative. So whenever you have a negative on the bottom, you're going to want to factor out a negative with the greatest common factor so that you can cancel that negative that's down there. All right, so we're going to take out a negative 4. We're going to undistribute a negative 4 from both of these terms. So that's kind of like dividing out a negative 4. So negative 12 divided by negative 4 is 3. Negative 8 divided by negative 4 is 2. Okay, positive 2, so we're going to have a plus. But don't forget that the second term had an I in it. And on the bottom we have a negative 20. But we can write that negative 20 as negative 4 times 5 if we wanted to. Or we could leave it kind of as a negative 20 and just kind of do this in our heads. But notice that now we have a negative 4 multiplying this. So these are factors. This whole thing is a factor and this is a factor. And we have negative 4 multiplying 5. And so we're going to kind of cross those out. So final answer, we got 3 plus 2i all over 5. Okay, so the goal of this assignment, again, was to divide like complex numbers. So that's what we did in number 10. We actually divided these complex numbers. we have to do that. We have to factor in order to do that. So we kind of took, in today's lesson, we kind of took a break from imaginary numbers for a little while, for about half an hour, to just talk about factoring and how to factor a binomial, which is a two-term expression, so that we could actually do this, right? The whole point was getting down to this. This is where we left off yesterday. We did multiplying with complex numbers and imaginary numbers. We did addition and subtraction with complex numbers. Today, we're doing the division, and it all comes kind of back to factoring. Because complex numbers they look like binomials. Like this guy right here, for example. Right? It looks like two different terms because it's a complex number. There's a real piece, and there's an imaginary piece. So, we're going to kind of apply that here. Now, remember that the goal of this assignment is to get you independent. You should be able to be independently doing these. So if you need more practice, you should probably, redo some of these problems. Make sure you can do them on your own, right? Get a separate sheet of paper, go back, try them again, make sure you can still do them. If you can't do them without the video, then you have some work to do. You really need to practice some more because we're going to have a test this week, and you're going to want to be able to do these on your own. I'm not going to be able to hold your hand on the test. So 2 here. I didn't do them for you. I want you guys to try them and check your answers, okay? If you're not sure what you did wrong, go back and go through some of these again. Practice the ones that you have a video for, and then go back and see if you can fix them, okay? So it may take some work, it may take some practice, but the goal is mastery and being independent, okay? All right. Now these ones here on the last little bit, 11 through 16, they actually kind of go back and apply to what we had up here. And what we talked about up here is that we don't leave I in the bottom. So here what it looks like here is we have a complex number in the top, and we're dividing that complex number by an imaginary number. And we want to kind of see how that works out. So we'll take it from 12, right? So again, the technique here is similar to what we did in 1 through 4. We're going to just multiply the bottom by I, because if we have an I times an I, we're going to get an I squared, which turns into a -1. But we have to make sure we do that on the top as well as the bottom. So let's do the bottom first. -12I times I is -12I squared. Okay, that's what we wanted because that I squared is a -1. And we'll deal with that in a second. Because we have a binomial on the top, we actually have to distribute the I to both terms. So there's a little bit of distribution here. So I have an I times -16, and then I have an I times a -20I. But that's actually okay because that gives us an I squared, which again is a -1. So I had a question today. Somebody asked me, can I just cancel both of these out, these I squareds out? And the answer is no, you can't, because this doesn't have an I squared. Remember, when you have a binomial or two terms with a plus or minus in between them, in order, both of these terms have to be divided by this guy. So you can't just cancel out the I squared here, because this guy is being divided by I squared. But it actually doesn't matter, because they're going to turn into -1s anyway. So let's fix what we have. We've got a -16I. Okay, that's the same. Now this right here, this piece is a -1, and so is this piece, a -1. So I have -20 times -1, which is +20. And I have -12 times -1, which is +12. Okay, so we've now got the I out of the denominator, which was one of our goals. Are we done? Well, we can actually simplify this fraction because 20 and 16 have a common factor. So the next thing we're going to do is we're going to go back to this step. So if you combine these problems here, 1 through 4, with these problems here, you basically get the last little problem set. Okay? So now we got to look for the greatest common factor of the top. And 4 goes into both of those. Okay? So the greatest common factor is a 4. We're going to now undistribute 4 from both of those terms. We're going to pull out a 4 to the front, right? And when we divide -16 by 4, we get -4. Don't forget there's an I there. When we divide 20 by -4, when we divide 20 by +4, we get a 5. And then we got a 12 on the bottom. Now we could rewrite this 12 as 4 times 3. Or we can just notice that 4 goes into 4 once and 4 goes into 12 3 times. And so for our final answer, we got negative, well, almost final answer. We got negative 4i plus 5 over 4. The reason why I say almost final answer is because when we have a complex number like that, we usually just write the I last. So the last thing I would do is just rearrange the order of the terms on top and put it over a 4. Okay, now again, really tempting to want to cancel those 4s, right? But it doesn't work, and the reason why is because this subtraction breaks this into 2 different terms that are both being divided by 4. So I can't just cancel out this 4 with this 4 because 5 also needs to be divided by 4. So we have factored out everything that could cancel. So we're done. This is how we're going to leave this. All right. 14. The beginning is the same. We just multiply by I over I. Okay, now I should probably say, if you needed help on 12, that's okay. Now you should be trying to do these on your own. Okay, go back and do 11 if you haven't already. Check your answer. Oh, we got the Jeopardy bell. All right, so you should be trying these on your own now, okay? If you're still stuck and you need another example, that's okay, but you need to keep practicing. So if you get through all of them and you can't get through a single one on your own, then you need to keep practicing. You need to keep practicing until you can get it on your own. So with that being said, you should try 1 or 2 of these on your own and then come back and check the video. All right, so I'm assuming that you've tried 14 already. Let's see what you came up with. So we got negative 15i. So this is the top. Negative 15 times I. We got negative 6i times I, which is negative 6i squared. Sorry, this is getting a little bit cramped. Let me get rid of this stuff. Probably shouldn't do that normally because like we want to show our work and stuff, but for the purposes of this video, I want to make sure you can see. Okay, on the bottom, we have negative 12i squared, right? I's get canceled. Oh, actually, that's very similar to what we had here. Those are similar problems. Okay, so on the top, I got negative 15i, but the negative 6 times I squared is negative 6 times negative 1, which is a positive 6. Remember, I squared is negative 1. And 12 times I squared, negative 12 times I squared is negative 12 times negative 1. So that's going to be positive 12. Okay, now we got to look for common factors. What goes into both of these? 3, right? Okay, greatest common factor is 3. Since the bottom is now positive, I don't have to worry about factoring out a negative 3. We're just going to pull out a 3. And that's going to leave us with negative 5i plus 2 over 12. So we undistribute the 3. We got to kind of divide out a 3 from these, and that's going to be up in the front now. And we have it over 12. But just like last time, 12 is 4 times 3. So 3 goes into 3 once, and it goes into 12 4 times. So this looks very similar to our final answer, but we're just going to rearrange. So 2 in the front, positive 2 in the front, negative 5i in the back, all over 4. There we go. So we wrote a few less steps that time. Hopefully you're getting better. All right, now 16 has a negative as well in it, so let's do one that actually doesn't have a negative in it. Okay, so you already have 13 in the answer key, but let's work through that one together, and then you can kind of try 16 on your own. All right, so starts the same way. Okay, now again, you should try this first. Before you go to the video, try it first. Finish it on your own, see what you can come up with. You got to be working towards independence. Okay, once you're done, you can come back and you can check. Okay, so when I distribute here, I have negative 6i plus 20i squared on the top, right? Distribute the I. On the bottom, I have 18i squared. Okay, the I squareds are negative 1s. So I'm going to get negative 6i minus 20 because negative 1 times 20 is negative 20. And then on the bottom I have positive 18 times negative 1, which is negative 18. Note that I have a negative denominator now. So when I have an I in the bottom and it starts out positive, it's going to end up negative, and now we have to deal with that. So what's the common factor of the top? Well, 2 goes into both 6 and 20, so the GCF, greatest common factor, is a 2. But we also need to factor out a negative to deal with that bottom negative number. So let's make this a negative 2. We're going to undistribute a negative 2. Okay, so on the top, when we undistribute a negative 2, we have a negative 2 on the outside, right? We're factoring out that negative 2. What we're left with is positive 3i and then positive 10. And if ever you want to double check, if you're not sure if you factored right, just distribute. Negative 2 times 3i is negative 6i. Okay, negative 2 times 10 is negative 20. All right, we got it. Okay, now the bottom is a negative 18, which we can rewrite if we want as negative 2 times 9. Again, we're trying to find the common factors here. And since 2 goes into that, we can say like 2 times 9, but it's also negative. So we want to cancel out the 2 and the negative at the same time, which will leave us with basically what's here. But we want to put the I in the back. So 10 up front, 3i in the back, 9 on the bottom. Don't try to cancel the 3 with the 9, because remember that 10 is also being divided by 9 in this scenario. And they kind of are being divided almost like independently, and that has everything to do with the fact that there's a plus between here. So if this was 10 times 3i, you could do what you want to do and cancel out the factors. But in this case, this is as far as we can go. If it's a plus or minus, you can only cancel out stuff that's in both of them, right? And there's not a 3 in 10. So if there was, we could factor out the 3 and cancel it, but we can't in this case. Okay, so you got basically half of the assignment now. Hopefully you did some of that on your own. We did 3 from the bottom section out of those 4 problems. We did, looks like 4 from the middle section, and we did 3 from the top. So not a whole lot for you to do on your own, but if you watched the whole video. But hopefully you're using this video correctly as a tool, a study tool, and not as a crutch. So make sure you're doing that. If you didn't get through a bunch of these on your own, and you only maybe did like 1 of them on your own or 2 of them on your own, you should probably go back and practice so that you're ready for Friday's test. Okay, thanks for watching, guys. I'll see you back in class soon.